que el aula estaba ocupada, así que hemos tenido que hacerla a una hora un poco estándar. Hoy tenemos, sorry, in English. Today we have with us Marcos López-Caniego. He's an astronomer. He did his PhD in cosmology in IFCA, and he's been working after that for Planck, with the archives of Planck, and then he was hired as a contractor by European Space Agency. And today he's going to tell us, I mean, he's been dealing with databases most of his career. He's an expert looking at it from both sides, from the astronomical point of view and from the more technical part. We have him here and his colleague to help us with the development of the databases and the archives of the observatories. And today he's going to tell us what you can do with the databases and the tools that the ESA is providing the community to do science. So hopefully you get out of this talk tools and information that will help you in your research. So whenever you want.
Okay, thank you, Eva. Good morning, everyone. Thank you for the invitation. So I'm going to talk about these tools that we have at the ESA archives to do your science. So this is a bit of a journey of the things that we are doing in the archives team for some of our flagship missions. So you may have seen this image before. So this is a summary of 50 years of space science. So we have all the ESA missions and missions from partner agencies that are either in legacy, in operations, or in development. And so this is all for astronomy. You will see in a moment the ones for heliophysics and planetary missions. So all of these missions are producing tons and tons of data. This data has to be archived, preserved, and maintained, and made available to the scientists to do their science. And this is not a simple task because we need to provide the tools and the services so that this data is really available for decades to the community. And as you will see, we have the amount of data that we have is growing and growing, and this is starting to become a challenge. So in addition to the astronomy missions, we have the planetary missions, as I was saying, and the heliophysics missions. And then this figure shows how the size of the data center that we have at ESA in Madrid, at the ESA Science Data Center, is growing. So a few years ago, when I joined ESA, 10 years ago for Planck was the largest archive by far, and we had some 150, 200 terabytes of data, and that was huge at the time, and it's still huge. But this is nothing compared to the new missions coming up. So Euclid, only this year we are going to be releasing 1.5 petabytes of data. And in the coming years, in only 4 to 5 years, we will go up to 25 petabytes. And together with all the other archives, we are already talking of the 30 petabytes figure because we will have more data than what is shown here. So this is challenging. So the size of the repositories is challenging. The diversity of products, formats, and data models is challenging. So we have to deal with all of this, but still make it available in an intuitive way to the users. The fact that these data sets are growing so rapidly is really building a big wall for many astronomers around the world to do science with this data. So this is why, as you will see later during the presentation, we are building a science platform so that people can actually go to this platform and have access to the data and the necessary computing resources to do reasonable science without having to download anything. Otherwise, it's impossible for anyone to download 25 petabytes of Euclid data. So we also want to facilitate the data discovery. So these data sets are becoming larger and larger. And only just to find the data in those huge repositories is going to be challenging. So we are providing the tools to facilitate the discovery. And also we want to foster reproducibility and to facilitate new ways of doing science with this data. Now that the AI is here to stay, then there are many things that you could not think about a few years ago that people want to do now with these data sets, and we are trying to facilitate this. So without going into any of the details, this is just a big overview of what is our data center. we have many missions from heliophysics, astronomy, planetarium, and now more and more these multi-mission archives that will slowly are slowly building with all the legacy missions and new missions coming up. It's very difficult to maintain so many different archives, each one of them with its own software layers and technology layers. So we are now moving towards this like a union of those missions that are similar to have them together, but this is happening slowly. Until then, we will have the usual archives. So this red box is the server layer, so you don't get to see any of this. What you get to see is the user interfaces. And from all these user interfaces, the one that you may or you may not know is ESASky. So I wanted to spend a couple of minutes on this because I've been working on this project for 10 years, and this is one of the coolest projects that we have at ESA that is not very it's not well known yet. So ESASky is a web application that is really sitting on top of the archives that allow the astronomers to navigate across datasets, not only from ESA, but also datasets from other partner agencies like NASA, JAXA, the Chinese Academy of Sciences, and also from ground-based observatories. So it's really powerful. You can change so we have like, it's very intuitive. You have just like a handful of buttons, but they are very powerful. You can change like the background images across wavelengths, and you can just like add these layers of data that you can choose from for each one of these wavelengths. Then there are lots of available HIPS images. That is this hierarchical format that allows you to zoom in and zoom out very quickly. So you can just like choose the HIPS that you want, but also because people are publishing this data in the bio registry in the data centers, you can also very easily load data that is living in other data centers, and then just go to your favorite object and then just navigate across wavelength. And there is a lot of science to be done with these tools, and I'm sure that you wish you had this during your PhD thesis, especially for catalogs. Then for observations, again, this tool, every time you move, you go to a different region of the sky, it will update in real time and then only show the data that is available in that field of view. So this is really powerful also for observations. It will show you the footprints for all these missions. Just with one click, essentially, it just show everything that is available in that field of view for all these missions. And then you can also download the data if you wanted to, or go directly to the archives where the data is living. Similarly, for catalogs, we have access to many, let's say, curated catalogs that we added to our databases, or that we point from ESASky to the databases in Madrid. But then for other catalogs, you can access the data also using virtual observatory protocols. You can access catalogs that are available in other data centers, and then just put everything in context in your window. Then we have access to VCR and also to the big data centers in the world. So we have direct access to the CADC in Canada, ESA in Caltech, ESO, Space Telescope, and HISARC. And then for each one of them, and then for the different subcategories of products, whether they are spectra or cubes or images or time series data, you can quickly access all the metadata, overlay again the footprints for all these products. And then if you wish to, just go to those archives and download it, or just like keep it here for this multi-mission or multi-frequency analysis that you are doing. We also give access to these tab servers around the world. So essentially, we can query the metadata not only from like these top astronomy data centers, but essentially from any astronomy data center in the world that is publishing the data repositories, the metadata for the data repositories in the bio registry. We can also access it from this tool. And then we also have access to this database of gravitational wave events and neutrino events that we get from NASA GCN. And every time there is a new event that is transmitted through the alert system, we ingest it in ESASky, and within something like 30 seconds to a minute, users can access information about these events. So if you are looking for an electromagnetic counterpart of a gravitational wave event, ESASky we think is one of the perfect tools to do like this kind of multi-messenger quick searches. We also have like this publications feature that we take advantage of the CDS in Strasbourg that is compiling this dataset and essentially tells you which publications are available for all these objects that have been cataloged at some point in any publication. Then we also have like this planning tool. At the moment it's for JWST and XMM, but if we had the footprints for the focal planes for the GTC or any telescope in the ISC, you could like use it there to plan your observations, which is really, really nice. And then we have like this target list feature. We provide some just for experimenting, but if you want to upload your list of targets, you can just like navigate through your favorite objects and take advantage of the whole of ESASky power. And we have a chatbot that you can talk to and navigate our data repositories using this chatbot. It's a bit of an old technology. We want to now to give it a new life with generative AI, but essentially nobody else has done anything like this in the past. So we are very proud of having like the first chatbot that you could talk to. So, and now there is another feature that is more for outreach, but still, as you will see, the science that you can do with outreach images is also huge. So, as I said, even though this is when you enter in ESASky, you are asked if you are a scientist or if you are an explorer. So if you are an explorer, you can just like navigate across the sky and look to pretty pictures. But some of these pictures really contain a lot of science. So we kind of facilitate. We keep them apart so that we don't confuse people, but still we give them access, and there are ways to overlay footprints from the various observations or catalogs on top of the outreach images. Because still, even though they are outreach images, I'm sure that you can do a lot of things with this. So we kind of facilitate ways to navigate this. And ESASky, by the way, it's a standalone application that you can access in sky.esa.int, but we also embed it in our own archives just to provide context to the observations from the various missions and can be customized. So if you wanted to have ESASky in your archives, it's very easy. So you could just like embed ESASky in your user interfaces and just use your own data and show it in ESASky together with everything else that ESASky shows. So it's a very flexible tool with a quite extended API that is used by other data centers. So you can also use ESASky within a notebook. We have a Jupyter Lab widget called ESASky that you install with pip very easily. We have an AstroQuery module like in every other archive at ESA for astronomy missions so that you can query the data repositories, and all of this is based on the table access protocol. Then if you go to the classical user interfaces, we have many for all of one for each one of our main astronomy missions. I will only briefly talk about the JWST1 and the HST1. So we have mirrors of these two archives at ESA because we are partner missions with NASA and with Canada. And to better serve the European community, we have a copy of the archives in Madrid. With there are some tools that we have that are not available in the other data centers. And this is the look and feel of these new archives. So we try to make everything very intuitive, but at the same time, we try to provide very powerful programmatic tools so that people can really take all the use out of the archives. So you have like a simple search area where in the case of Hubble, you can select your filter by proposals, instrument, and other filters. And then we use ESASky, as I was saying, to provide context for these footprints, and you can overlay other catalogs. Everything that is available in ESASky is available in the embedded instances of ESASky, which makes it really powerful. And then we provide some quick visualization or quick exploration tools. So we have visualizers for fixed images that go a bit beyond the preview, the typical. We provide preview images of JPEGs or PNGs or whatever we have, but then we also provide actual visualization of the fixed images. For spectra, we have spectra viewers, cube viewers for the case of JWST, for the MIDI. And then in some cases, like in the Hubble archive, we have for the Hubble catalog of variables, we have some, we go a bit beyond and have like these custom views where you can look at the object in the sky, then get information about the light curves or variability. But then Jupyter came. So I'm sure that everyone in the room is using notebooks in one way or another, or is using Jupyter Lab or Jupyter Hub in some way. or even Jupyter AI now. So how did this impact us? So at the beginning, since everybody in the community in astronomy, everybody is using notebooks now. So we started to provide within the document, within our user guides, we provided example notebooks so that people could really explore the data contents of the archives with some of these notebooks. This was very well received by the community. But then we wanted to go a step further. So for some of our archives, what we are doing now is when the user goes to the archive, looks for a particular object in the sky, in this case M74, you go, you see what's available there, you look for your observation of interest. And what we do is we generate in real time the notebook that will mimic the same query that you have done by clicking here and there in the user interface so that you can reproduce it in a programmatic way from a notebook. Because maybe now that you found the data that you want to use, maybe you prefer to go back to your notebook and then do all your science directly in your notebook without having to download anything so it's as easy as, so we generate these notebooks on the fly, and then they are downloaded to the user's computer, and then you can just like execute it, and it will do this, and you will get the exact same result as you see in the UI. And the interesting part of this is that if you are downloading the notebook to your computer, then you can take advantage of the download functions that we include in the notebook so that you can download the data. But if you are using this notebook within our science platform, we are putting some examples we extend the query that you've done in the UI to actually find where in the file system the data is living so that you can read it directly. So there is no need to download anything. You just read the data that you just search and then just use it without having to download anything locally, which for Hubble is nice to have. For Euclid is really a must. And yeah, so I think this is a very nice functionality. Then, so I briefly mentioned the science platform. So why did we decide to build a science platform? So our science platform is called ESA Datalabs. It's in beta stage, which means it's there. We have like a zillion users, but it's not publicly available. So you really need to request access. And then when you request access, essentially you have to go here, you submit your request, you provide some details, and then typically you are put on a wait list. But if you have an invitation code that we are producing in various contexts, then you will request, will get approved automatically. And if you want to find one of those, I will show you where to find some of these invitation codes. They are kind of hidden in some of our archives. So if you find it, you deserve to have an account in Datalabs. In the future, I guess this will be more openly available, but some control, as you can imagine, some control needs to be imposed, and you need to register with an academic or institutional address. You cannot use a Gmail account to request an account in Datalabs. So it is moderated to some extent. So again, what is the purpose? So until now, you went to an archive, you search for some data, download it, you process it, and then if you find something interesting, you try to publish it. But now what we want to avoid is people downloading data unnecessarily. And this is for missions like Euclid is a must. But then for other missions, you would think that maybe for data from for other missions like Hubble or James Webb, or even from a ground-based observatory, you would think that this is not needed. I will just download my few gigabytes of data. But what we are arguing here is that by working in this platform, so we are giving you many more things to encourage people to really work in the platform. So we are giving you access to data from all the other missions, and also to some computing capability and to some shared areas that you can work with your teams. So this will facilitate just to try to convince people to work on the platform. So we also provide some dedicated software. So this is not only Jupyter notebooks. So you can have other applications. You can have TopCat or you can have DS9 running within the platform. So you could have like one browser window with your DS9 open and then another browser window with your notebook, and then you could be doing your science as you would do in your normal workstation. It's not identical, but it's similar. And then we provide For example, for James Webb, I will mention later, we provide a calibration pipeline that we keep it updated. We update every day the calibration files from a space telescope, so people could really do their analysis with James Webb data without having to download any data, without having to install any pipeline, and without having to install the calibration files. That is quite they are quite large. They are already at the 1 point something petabyte. No, terabyte, sorry. Then, yeah, so we provide this specialized software to analyze the data. Then we also provide the actual data. So not everything is available, but most of the repositories is available, particularly for the higher level science products, for all the ESA missions. So in this case, you have access to all the HST data from all the instruments, and from James Webb, from Euclid, you will have it, from Gaia. So you really have everything like really accessible to you, more or less programmatically. And this can be very powerful. And in addition to the data from all the missions and all the data from your mission of interest, you have this teams area. So you can request to build a team just because you are a team of colleagues that you are running a particular project that requires access to data, whether it is public data or it could be restricted access data that is not yet public. So you can request it typically to the help desk that will redirect this question to the project scientists of the mission of interest, and then they will approve it or not. But essentially, what they are giving you is an area where you can really collaborate. You will share some hard drive space, and then you will have access to resources to execute your pipelines and your analysis. And then it's just like really your area. You don't have to, and this can be very, very powerful. And then now we are trying to see how to do this connection between the archives and data labs. So some minutes ago, I was showing how we generate a notebook in real time based on a query. But now what we want to do is instead of the user having to download the notebook and then upload it to a platform or use it locally, we connect the archives with the science platform. And now we are just showing here, this is an example of one of the invitation codes, so JWST_archive. I can show you it again. So if you just try to register yourself with that code, it will work. Yeah. So we want to make this connection between the archives and data labs directly. This is here just showing how to this widget essentially for if you've never used data labs from the archives, essentially is guiding you through this like cumbersome steps on how to do everything on what really is needed to do the connection between this query that you just did in the archive and data labs. If you know what you are doing because you've done it in the past, it's a 2-second process of just like clicking on one thing and then your notebook will open automatically in the platform. And you can just execute it and have access to the file system directly without having to really download anything. So not only did we provide example notebooks to show people how to access our servers, and then we generated these notebooks in real time based on the user-specific query so that the users could download it. But now we are connecting the archive with the platform so that these notebooks can be executed like seamlessly within the platform. And this is just like showing again an example of, in this case for JWST, on how to find the data. And then for the particular case of JWST, I think later in this presentation, in the video, I'm also showing how to really run the actual pipeline that I was mentioning before. So this is how it looks. So when you launch one of these data labs or data apps, as they call them, so you have access, so you can access either the data that someone has decided for you to see. So in this case, for JWST, I decided which volumes will be accessible to users. So I just like include them here I configure it so that when you launch one of these data labs, you will have direct access to these volumes. But if you have decided that, if you as user go to the platform and decide that you also want to see data from Hubble or data from Euclid, you can just like mount those additional volumes, and then they will also be visible to you. So this is big, and this really becomes very powerful. And so when you start up the JWST Data Lab, you get a Getting Started notebook. This is the case for all of our data labs. It explains you what are the typical resources that this data lab will have in terms of memory and in terms of RAM memory, cores or execution. Also, what is the size of the workspace, and also in the case of JWST, how to access the pipeline and how to use the calibration files and how to configure your environment to use all these blocks. So in the end, what we are providing is all the building blocks so that you can do your science within the platform. The learning curve can be very easy for some or can be a bit less easy for others, but in the end, we are always willing to improve. So any feedback that is given to us is always taken into account. And also, I was mentioning this in a previous meeting this morning. So we are in contact with the developers of the Jupyter project, and they are willing to extend the capabilities of the various Jupyter components to facilitate the research in astronomy. So if you had a wish list of I wish I had this or that in Jupyter, maybe come to us just because we have like direct line to these guys and they are like really willing to improve on the project. So if you have a specific request, I'm happy to channel it to the developers of the Jupyter project. And then yeah, so essentially this is as I was saying, showing how to execute this. Then we also include for the case of JWST, we include in Datalabs JWs, which is a visualization library that has been developed by a space telescope that is very much focused. It can be used for any type of product, but it works very well for JWST products. So we installed it in our platform so that people can take advantage not only of the data and the calibration files and the pipeline, but also of these visualization tools. And we also provide example notebooks on how to process the various types of JWST products with the pipelines, and also how to visualize them with this library. Then coming to Euclid. So Euclid is the big beast in any aspect. I mean, there are many people working in Euclid. So there are people working in Euclid that are the IAC, and we have some of our super mega heavy users coming from the IAC. So if you are in the room, you know who you are, because you've been challenging our systems very heavily. But this is good because this is giving us the necessary training to be ready for the public release coming up in a few months. The big public release, because if you didn't know, there is a small public release coming up on Wednesday, of the Q2 data. So in Euclid, because of the size of everything, ESA decided to go one step beyond what the standard data labs and build something called Euclid Data Space, which is a portal that really contains both access to the data, ESASky as visualization layer, and all the power computing capability of ESA Datalabs all in one place. All enhanced with information from the mission and from the Euclid collaboration that is also providing material for this portal, and this will grow further. And at the moment, if you have a Datalabs account, you can already access the Q1 data, which are these 3 deep fields, which you can also visualize in ESASky. And this is, I should have added a video, because when you look at this in ESASky, you just like zoom in, and this never ends. Really, really nice. And then all of this is possible. I mentioned it a couple of times. All of this is possible because underneath, or under the hood, we are using these virtual observatory compliant APIs. And then we are using these protocols that other big data centers are using that allow us to really to interoperate and to do things that maybe we couldn't do ourselves because maybe we don't have the necessary resources. So we all share like all this knowledge within the virtual observatory. And then yeah, so here we are combining using bio protocols underneath the power of data discovery that provides the Astro query with the visualization tools like ESASky that is accessible from the user interface, and the power of data labs. And if you combine Astro query with the direct NFS access to your data, we think that this is really super powerful. And for the case of Euclid, it's just the only way to really do many things. There will be use cases in Euclid where you can just download the data, but there are many use cases that you can only do if you have access to this platform. And this is similar to when you launch the Euclid data lab or data app. You also have a getting started that explains you similar like before, what are the resources available to you and what are the libraries that that are pre-installed for you in this container, and then how to access the data and example notebooks. So we are really trying to help users navigate the repositories and do the science. Again, if you have any kind of suggestion, we are always happy to implement it. And now there is just to give you a pinch on some AI things that we've been doing. So at ESAC, we have the data science team that is coordinating all the various AI initiatives. And then within this team, we have the chatbot that I mentioned at the beginning, but now there are many other things being done. Well, this is the chatbot. Now we are playing with agents. This is now the new hype. So everybody wants to do AI. Everybody wants to take advantage of these agents. So they are like these little minions that will do your work and your papers. So we are just training our minions to do so that you can use them. And the one that we've been thinking is for Euclid again, because Euclid is not the typical mission. So in a typical mission, you will have 1 to 12 types of products. In Euclid, we have over 200 different types of products, very different, with a very complex data model. So we are proposing to have a chatbot that underneath is using all these technologies to learn about the mission, to learn about the data model, so that you as user can just go to this chatbot and ask something. Maybe you are interested into some weak lengthening two-point correlation function, but you don't know the crazy Euclid name for that particular product in the data model. That is something ugly and difficult to remember. So we're trying to make this connection between natural language and the data model. And then once this is done, we propose to have an agent that will generate a code that will query the archive and come back with an example, a valid example for that type of product, so that the user can really get familiar with that type of product. And then we will have another agent that will take this code and dump it into a notebook that will be reviewed to make sure that it works, and then make it available to the user, or by downloading it or by using it in our platform. So we've been experimenting with this. At the moment, this is just an experiment. This is not a production system, but essentially we got this example running, and we've been presenting it in some AI conference in the field in the orbit of data centers, astronomy data centers, where essentially we are demonstrating that it is possible to use all this technology to talk. Essentially, you talk to the system in natural language, and then this combination of systems, because there are many, will make like these little connections that will talk to each other, and eventually will provide this example notebook that users can use. Because what I was showing before is that we already have the capability of generating in real time example notebooks for a specific query. But now we want to go beyond and let the user really speak to the system, and then this system will do the magic and come back to the user in this case, with a description of what is the model about, the product about, and what is the name, where is the product located, and how to find it in our databases. This is just a toy, like many other prototypes that we are building, but there is the community. I mean, we were thinking about this, and in parallel, there was a request coming from the community within the Euclid consortium that they would like to have something like this. So this is very nice that we are aligned with the needs of the community. So it's not that we are only like inventing things that nobody uses. So we hope that eventually we could build this. And then we were experimenting with another one. This one is a bit more of a lazy guy, the lazy version of the other one, which essentially you go to your chatbot and you say, okay, can go to the European JWST archive and give me what data is available at the location, in this case, of NGC 3324. And then you sit down and see the machine thinking. And essentially what the machine is doing is just looking for official sources of information. So first it went to the Cosmos page, which is the page at ESA where we have the links to all the archives. It found the archive for the JWST archive. It navigated autonomously to this website. It found that there is a field where you can enter the object name, enter the object, clicked on enter, got all the data, got the ESASky up and running, showing the footprint for this particular observation. And then eventually it will bring up the preview image. All of this just by looking. So you just sit down, and then the next thing will be to ask the thingy to analyze the data, do your photometry, cross-match with whatever, and write some paper. And then we will see this soon. But until now, we're at the level of just giving the people the opportunity to navigate our archives in a very, very simple way, because for us that we do this every day, we just go to the archives, you know where to click, you know where things are, and you find them in 5 seconds. If you have never been exposed to the Euclid archive that has like 1 million options, or the Planck archive that has like 10 million options, then it can get difficult, and the learning curve is not always easy. So we are experimenting with these kind of toys. So just to wrap up, so we are providing like this suite of data discovery tools. So we started with ESASky, sitting on top of all of our archives. And then for some of the archives like JWST and HST, where I was the support archive scientist and support scientist, we got into this process of generating notebooks in real time, then making the connection with the science platform. And now all of this knowledge is now being used for Euclid, which is at the moment the most challenging mission that we are dealing with. And Euclid is really benefiting for all of this previous work, and is the Euclid portal, the Euclid data space, will essentially have all these features just to give users the possibility to access data. And then just to finish, it's all about data discovery. So now with these petabyte archives, it's just now the challenge is to find the things. So we are trying to help with this process, and we always welcome suggestions from the users. So thank you very much.
So first one is, you plan to include the Gaia question in your data in this Web2, and if so, will you publish the data continuously as a data release at Sphere or some link? And the second question is, are we able to download the data in a parallel way? We have millions of data that we want to go to
So yeah, for the Gaia DR4, it will be released, obviously it will be released in the Gaia archive. In parallel, it will be released in ESASky. And they are always aligned. So it was, I think, 10 days ago, we released the latest XMM catalog in ESASky. This was done at the same day and the same time as it was done on the archive. On the XMM archive for Gaia, we always do the same. So we have a release time, and then they release it on the archive side, and then we release it on ESASky. So we are always, we share the teams. So we are always aligned in that sense. It could be that sometimes we do it a bit later for some reason, but in general, we do it at the same time. And then the other question, you can always download everything. So we provide the tools so that people can download. They can download one image, or they can download the whole JWST archive if they wish to, or if they have a place to put it. However, sometimes it doesn't look reasonable to download like a full archive, depending. I mean, if you want to do, depending on what you want to do, if you want to look for, for tracks of satellites in your HST images, then you want to have the whole thing and then just do a blind analysis of the whole data repository. But if you are interested in some specific science use case, maybe it's not reasonable to download everything. But we provide the tools for bulk download of the archives as well. And in fact, people are downloading the archives.
Questions? I have one. I think the the way you are moving to the AI-specific tools for astronomers, I think is less prone to mistakes by the users that know less the missions. I mean, if you train properly, the AI is probably going to give better results. Are you training them? Are you planning training them mission by mission, having specific tools for each mission, or for astronomy?
Yes. So this is still on the making. So the introducing AI in all this data discovery process within the ESA Science Data Center is part of the new technology roadmap. So this will happen. There are some of these components that can be shared across missions, but then the training with the specific knowledge of the mission has to be done mission by mission. But this is not that difficult. So we suspect that I don't know which archive will be the same. I don't know if it will be Euclid or JWST or Plato, or we don't know. But whoever does it first, everybody will benefit from it, because most of those building blocks will be the same, and only essentially this so-called RAG pipeline, this retrieval augmented generation, which is where you take an existing model and you enhance it with the specific knowledge of a mission. This is very easy to do from one to another. Easy meaning that is that at least we think it can be done, but it has to be done, and then it has to be validated, and then we have to see how to pay for all this, because all these toys are resource intensive. But in principle, if you do it for one mission, it will be easy to do it for the others.
Okay, there is one question online. If you're planning to include Nancy Grace Roman into the... I finished reading.
What was the question again? I didn't get it.
One is asking, are you planning to include Nancy Grace Roman Space Telescope data?
I think this has not been decided. There is ESA has an archive. There is a project scientist for Roman that has taken the position very recently and is in a space telescope together with the rest of the ESA team at the space telescope. So there is a representation of ESA in Roman. Whether the Roman archive will be much larger than the Euclid one, so it's not straightforward. It's not like we copy the data and we bring it to Madrid. I don't think this will happen. But it could be that there is some parts of the dataset that can be interesting for specific use cases that are relevant for Euclid, that they are shared in some way that is useful to the users. But I think all of this is to be decided. But we will see soon, because Roman is launching in a couple of months. So.
About this thing of bringing the science to the data portal, how do you deal with people that ask for installing codes or Python libraries? How do you deal with this?
So if we allow people to install their things? Yes, we do. Some others don't.
Okay.
We do. And there are risks associated with that. But so far, I think what ESA is, they're probably trusting people to do not mining Bitcoins within our platform. There are tools to monitor the platform to see if there are anomalies in the way the users use the platform. But in principle, you can bring your own pipelines and install them, and essentially, and we show how to do it. So we show people how to go to their personal area or to the team area and create a Conda environment with their own things, so that next time when they come back to the next session, everything is there available for them. So yes, and you can also bring in your data within the limits, the 100 gigabytes limits that we give. You can also bring in your data or your favorite catalog that you cross-match every day and just have it there.
Thank you, Marcos. The way I understood, you have a wonderful system that allows to connect between our data across different ESA missions. Is there a way to connect to other servers like CDS or even the ESA archive?
So there are different levels of answers to that question. So within ESASky, you can already query in real time the metadata from all the big data centers in the world. In real time, you see what's available and what is not. And we provide links to those centers so you can go, so that you can quickly, once you find whatever you are looking for, you can go there and download it or whatever they allow. The actual access to the data directly from within the platform, the only way to do it will be to use AstroQuery to query those other archives and download the data. But they are not yet interoperable in that sense. So there have been discussions of deploying Datalabs in other data centers so that this level of interoperability is larger. But this is an ongoing discussion that there are benefits of having an instance of Datalabs running in other big data centers so that they can share essentially all the software, all the images, all the applications. But this is complicated. There have been some prototypes, some experiments. So this is doable, and this has been demonstrated. But there is we will probably see this happening sooner than later. But it's still on the making.
Thank you for the talk. So may I ask how expensive to train those kind of AI agents? Are you like building them fully from the start or using those provided by like open AIs or whatever?
No, at the moment everything is like really custom. So we are building. I mean, we use the models from other people, but everything else we are just like building with the various building blocks that you find on around. But because of the restrictions to use AI systems within our IT infrastructure, it is not straightforward to. I don't know how to say it. We cannot do anything we want. So we are very limited to the experiments that we can do, just because we are working in a very complex corporate IT infrastructure, and we cannot just like install anything and see and play with it. So we are a bit constrained on what we can do. But at the moment, what we do is just we really build it from little blocks here and there so far.
Thank you.
Well, if there are no more questions, I would like to ask you one. How many of you did know that ESASky exists? Okay. And MAST? How many of you use MAST? More or less the same people. So, okay.
We need to advertise ESASky.
I think you need to advertise ESASky a little bit more. I mean, it's a very powerful tool. So, thank you, Marcos. And thank you all for coming to the talk.
Okay.